Hello again, thanks for joining me. This is Astronomy Daily and I'm your host, Andrew Dunkley. Hope you're ready for your daily dose of astronomy and space science, and a lot to talk about today. And joining me as always is our intrepid interstellar reporter, Halley. Hi, Halley.
Hi, Andrew, I hope you're well.
Very well, thanks. And I believe you've been rehearsing with my brother Steve because he'll be taking over the program for a few weeks while I take a little break.
I'm really looking forward to working with Steve. I love his sense of humor.
Yeah, he's a funny guy, or at least he thinks he is. No, he is. He's a good guy, and I'm sure people will enjoy having him host the program with you, Halley.
The Astronomy Daily Podcast with Andrew Dunkley.
And we've got some very exciting news to report today.
Yes, Andrew, the double asteroid redirection test that we witnessed a few weeks ago has been declared a success by NASA. Humanity's ability to stop an incoming cosmic object from devastating life on Earth has been proven possible. The fridge-sized DART spacecraft impactor deliberately smashed into the moonlet asteroid Dimorphos on September 26, pushing it into a smaller, faster orbit around its big brother Didymos, according to Mission Chief Bill Nelson. DART shortened the 11-hour 55-minute orbit to 11 hours and 23 minutes, thus speeding up Dimorphos' orbital period by 32 minutes, exceeded NASA's own expectation of 10 minutes. Bill Nelson declared that NASA is now a serious defender of this planet. Astronomer Avi Loeb has spoken out about the many UAP sightings over Ukraine, where objects are seen flying at speeds that which cannot be achieved by human-made craft. After reading the astronomers' highly detailed report, Loeb decided to publish his own, where he dismissed their extensive research as a miscalculation. Reducing their inferred distance by a factor of 10 is fully consistent with the size and speed of artillery shells, Loeb wrote in the report. He added, "I am not sure what to make of the report. Ukraine is in a military conflict with a lot of human-made activity in the sky. This must introduce a lot of noise for any search for objects that are not human-made. In science, we aim to maximize the signal-to-noise ratio, and so Ukraine would be the last place on Earth where I would initiate UAP studies." Loeb seemingly dismissed all of the reports in one fell swoop, despite his own lack of any meaningful evidence to make his claims. Japan is scheduled to launch a variety of technology demonstrating payloads to orbit tonight. A Japanese Epsilon rocket is scheduled to lift off from Uchinoura Space Center at 8:50 p.m. Eastern Daylight Time tonight. That's 0:50 GMT and 9:50 a.m. local Japan time on October 12. The mission, known as Innovative Satellite Technology Demonstration 3, will be Japan's first orbital liftoff of 2022. The main satellite flying is called RAISE 3, which is short for Rapid Innovative Payload Demonstration Satellite 3. The 220-pound, 100-kilogram spacecraft carries 7 separate technologies that will get a test in Earth orbit. Among those technologies are 2 small experimental thrusters, including one that uses water as fuel, a drag sail designed to help satellites deorbit more quickly and efficiently, and a deployable membrane structure that can generate power and also serve as an antenna. 5 tiny CubeSats are also launching on the Epsilon tonight as rideshare payloads. Inmarsat has won a $980 million U.S. Navy contract for global communications services. Inmarsat government announced it won a 10-year contract to provide broadband satellite and terrestrial communications services to the U.S. Navy. The company was the incumbent on the previous CSSCI contract and won the recompete. The contract is for managed telecommunications services, integrating Inmarsat Global Express Ka-band, as well as C-band, Ku-band and X-band frequencies. Navy users include units located at fixed sites, as well as mobile maritime, airborne and ground platforms. The agreement also covers commercial teleport services, backhaul connectivity, monitoring and control, operations, information assurance and cybersecurity. And that's the news, Andrew.
Thanks, Halley. We'll catch up with you towards the end of the show. But back to that exciting news from NASA that the double asteroid redirection test, the DART impactor test, was a wholesale success. September the 26th, NASA smashed a refrigerator-sized spacecraft into an orbiting moonlet of an asteroid, Dimorphos. which was orbiting Didymos, and they have knocked it off course. Basically, what that has done is reduced the orbital speed and plane of Dimorphos around Didymos. Now, the orbit has been shortened by over 30 minutes, which is much better than NASA had anticipated, 32 minutes to be exact. They expected they'd be able to shorten the orbit by 10 minutes, but it's been reduced from 11 hours 55 minutes to 11 hours and 23 minutes, which proves that direct intervention can change the direction of an asteroid that may one day threaten Earth. Now, it's early days. This was a small experiment in the scheme of things, but it proved that this could be done. Now, this asteroid pair loops around the Sun every 2.1 years, and it poses no threat to our planet. But they are really good for studying a kinetic impact test like this. And it's certainly an exciting outcome as a consequence of a very long-haul experiment indeed. And so, everybody's cheering. You can't get much of a better result than that. So well done to the DART team at NASA. And I might try and catch up with Fred Watson and have a chat to him about it as well. And we might run that on tomorrow's edition of Astronomy Daily. Now, the James Webb Space Telescope has been in the news very regularly since it was commissioned, and rightly so. It's made some amazing discoveries and taken some extraordinary pictures. And now its focus might be on the outer reaches of our solar system, around those icy worlds beyond Pluto. Since it was launched in 2021, the JWST has sent back photos of distant exoplanets, the nebula nurseries in the immediate vicinity and beyond, some amazing galaxy photos dating back 13 billion years. We've seen them all. Well, Pluto, as you know, was reclassified as a dwarf planet in 2006, but it's also categorised as both a trans-Neptunian object and a Kuiper Belt object. And planetary scientists consider that a TNO, as they call it, trans-Neptunian object, because Pluto's orbit sometimes crosses Neptune's, and a KBO, a Kuiper Belt object, because it's one of the biggest objects in the Kuiper Belt. So it gets two categories. The worlds and objects beyond Neptune are largely unexplored. And that's why the James Webb Space Telescope is going to be paying particular attention to that region. There's so much that we don't know, and so much that we need to learn about the outer edges of the solar system as we know it. And the Kuiper Belt is a big disk in the outer solar system that stretches around 30 astronomical units, where Neptune orbits at about 50 astronomical units. So it's a big area. The Kuiper Belt was actually a concept proposed by Gerard Kuiper in 1951, although it's sometimes called the Edgeworth Kuiper Belt to include Kenneth Essex Edgeworth, who also described it in 1943. The uncertainty about what to call that disk led to the creation of the term TNO to describe objects in that region. But the James Webb Space Telescope will be studying the Kuiper Belt in depth, and hopefully will provide us with some really interesting answers as to what is really happening out there. We don't know a heck of a lot.
The Astronomy Daily Podcast
with Andrew Dunkley.
Now let's move to Saturn's largest moon, Titan. And NASA is launching a mission called Dragonfly, which will touch down on the dunes of Titan in years to come. The launch is 2027. Dragonfly is a rotorcraft that will arrive in 2034 and explore Titan from the air, not unlike the helicopter that's being tested on Mars in some respects. Its range will be far greater than any wheeled rover, and the Dragonfly will be capable of covering around 16 kilometres or 10 miles in each half-hour flight, according to NASA. And over the span of its 2-year mission, it will explore an area hundreds of miles or kilometres across. However, before taking to the sky on its own, Dragonfly must first arrive on Titan under parachute, a soft landing on a frozen terrain. It will be a haphazard journey, but one hopes that it will be successful and we will learn so much more about this rather volatile world. And while we're talking about strange craft taking to the skies, here's one that they're planning to deploy on Venus. It's from JPL. It's the Venus Aerial Robotic Balloon prototype, and it's apparently done well in early testing. A scaled-down version of the Aerobot, as they're calling it, that could one day fly in the Venusian skies, successfully completed 2 tests in Nevada, test flights that is, marking a milestone for the project. The intense pressure, heat and corrosive gases of Venus's surface are enough to disable even the most robust of spacecraft in a very short period of time. But a few dozen miles above, it's not so nasty, and this is why they're looking at this particular idea as a way of exploring Venus. It kind of looks like a big shiny hot air balloon. So the testing continues, but it looks like that could be a go for a future deployment to Venus. So that's also very exciting. And that just about wraps it up for another day. Halley, anything before we finish?
Yes, Andrew, happy National Arthritis Day. It's good that they recognized a day like that for humans like you.
Yeah, well, nice attempt at an insult, but 2 things. I don't have arthritis yet. And I'm not American, so it doesn't count. And you just better be careful or you'll get some arthritis in your cooling fan, I reckon. Anyway, we'll talk to you soon.
See ya.
And that's it for another show. Thanks for listening. Don't forget to visit our website at spacenuts.io. Click on the Astronomy Daily tab and catch up on those stories and more, and subscribe to the newsletter. It's absolutely free and will pop into your inbox every day. And don't forget to leave your reviews at your favourite podcasting platform. And while you're on our website, listen in to past episodes of Astronomy Daily and Space Nuts, of course, with Professor Fred Watson. Until next time, thanks for listening. This is Andrew Dunkley for Astronomy Daily.
The Astronomy Daily Podcast
with Andrew Dunkley.